Hi, in this video, we want to look at the identity element or the identity property. Earlier, we've looked at the concept of binary operation, where we look at the meaning, look at how to solve basic questions underneath binary operations, and move on to talking about the properties of binary operations. We've talked about properties like closure property, the commutative property, the associative property, the distributive property. So now we want to talk about the identity element or the identity property. So we're told that if E, being an element of real numbers, is the identity element under a binary operation star on a set R of real number, then A star E equal to E star A equal to A. So basically what this is saying is, what do we need to combine to A underneath the operation, whether A star E or E star A, what we need to combine that gives us A exactly. Now, for us to understand the concept of what it means for a number to be the identity element of another number, then let's look at it from the concept of addition. So let's say I want to add a number to another number to get me the same number itself. So what do I mean? So let's say I have 5. So what do I need to add to 5 that gets me 5? Or what do I need to add 5 to? Again gets me 5. Once I can know the number that I need to add to 5 that gets me 5 becomes the identity element. For addition, we know our identity element has to be 0 because 5 plus 0 gives us 5, or 0 plus 5 gives us 5. Same is true for subtraction, but of course, not in this regard. Remember, for subtraction, the order matters. So let's say I have 5 subtracted by or subtracted from a number, and I want to have 5 itself. So 5 minus what gives me 5? So I can say 5 minus 0 gives me 5, or 10 minus 5 gives me 5. So this is different for subtraction. So you have to note that. Of course, when we talk about multiplication, what is the identity element of multiplication? So let's pick a number 10. What do I need to multiply 10 by that gives me exactly 10? Or what can I multiply with 10 that gives me exactly 10 also? So here, we already know that 10 times 1 equals 10, or 1 times 10 equal to 10. So multiplication, the identity element for multiplication of real numbers is 1. For that of addition is 0. For subtraction, most texts will tell you it has no identity element. So you get, because 5 minus 0 is not the same thing as 0 minus 5. Hence division also. So the same thing is true for division. I hope this makes sense. So let's look at a more valid approach or an example how to find the identity element of a given operation. So we're told that an operation is defined on the set R of real numbers by A star B equal to A plus B minus AB, where AB are all members of the real numbers set R. So we have to find the identity element. We have to find the identity element. So from our definition, we know that for identity elements, it means by the time I combine the first member or the first element with an identity element, I have to get the number itself. So that is A star E must be equal to A and also must be equal to E star A. So whichever one, whether you want to use this or you want to use this, you should arrive at the same answer, which is A. All right, so I'm going to be cleaning this. So we're just going to be using one. So it doesn't matter which one. So I can use the first one, or I'll use the first one in this example. Then the next example, I'll use the second part. So that you see that no matter the one you decide to pick, you still arrive at the same conclusion or at the same answer. All right, so let's use the first part. So let's use A star E must give us A. So of course, here our operation has been defined as A star B equals A plus B minus A B. So definitely my A will be equal to A, and then my B will be equal to A, and then I equate it to A to find the value of A, or what my identity element would be. So without wasting much time, so let's do that. So this becomes, anywhere I see A, I'm going to write A, and anywhere I see B, I'm going to write E instead of B. So A plus E minus AE, and then I have to equate it to be equal to A, because A dot A star E must always be equal to A identity element. All right, so from this, I will take A to the other side. So taking A to the other side, this becomes A minus AE is equal to A minus A. A minus A. So A minus A. All right, so factorizing this, we have E, then 1 minus A is equal to A minus A gives us 0. I'm making E the subject of the formula. That is, I want to divide both sides by 1 minus A. Sorry, let me write this very well. 1 minus A. So divide this also by 1 minus A. And my E, so this cancels out. Then 0 divided by anything returns 0. So my identity element for this expression A star B has to be equal to 0. So this is how we solve questions underneath identity elements. Quite easy, isn't it? So let's try and look at the second example. All right, we've been told that a binary operation, delta, is defined by P delta Q equal to P plus Q plus root 5 on the set R of real numbers, where PQ obviously are elements of set R. We have to find the identity element E of R under the operation delta. So under the operation delta. Okay, so what do we do about this, or how do we go about this? Again, we want to write what's it called? I'll call it equation. So for identity elements, we already know that when we combine, so which operation are we dealing with now? Delta. So when we combine, or what do we have to combine with A underneath this operation, that gives me A itself. So either we write it this way, or we write it this way. So since we use the first one in the previous example, so let's use the next one in this example. So let's try and clear this and write it smaller so that we can have enough space to work with. Okay, so again, what do I want to write? I want to write E, so delta A must be equal to A. All right, so E is my identity element, which is what we're looking for. So I'm going to let P to be equal to E and Q to be equal to A. You can see that the expression on the left-hand side, E delta A, is similar to the expression on the left-hand side of this defined binary operation. So P delta Q, so E delta A. So what do I want to do? Anywhere I see P, I want to write E, and anywhere I see Q, I want to write A instead. Now you can decide to use A, or you can decide to use the expression what you are given in this question. Since we are given Q already, so we don't always need to write A, but know that okay, A means Q. I hope that makes perfect sense. So let's start. So anywhere I see P, I'm going to write E. So this is E plus. So anywhere I see Q, let's still write Q. Then it has to be equal to Q. So this is the only this thing. So I hope you get what I'm trying to say. So if you want to use A, it is fine. The identity element is what we're looking for, not A, not Q. But if you are using A, then it has to be equal to A. But if you are using Q, it has to be equal to Q. So, but let's just stick with Q because that's what the question has given us. So E plus Q plus root 5, and this must be equal to Q. So E plus Q plus root 5. So you can see this is P plus Q. So P is Q, Q is Q, and then root 5 remains root 5, equal to Q itself. So what's the next thing? We want to make E the subject of the formula. So making E the subject of the formula, we have E is equal to Q minus Q minus root 5. So Q minus Q, that's 0. And my identity element simply becomes minus root 5. So this is my identity element. Quite simple, isn't it? So let's take more examples concerning this. So in this example, we're given a table and then we're told that the operation star is defined on the set T, A, B, C in this table that will be given below. So from the table, we're asked to determine the identity element for the operation. Now, this question has been grateful enough or graceful enough to give us the table itself. Sometimes they'll give us the sets, we'll define the operation star. So we have to, first of all, fill in the table. Then from the table you filled, you have to determine the identity element for the operation. But since we have the table already, and then the what's it called? The members of the table has been filled rather, then definitely we can just move on straight to finding our identity element. And how do we find the identity element? We already know the identity element from our definition. So let's say we have A and we want to combine A with another thing or with an identity element. By the time we combine this, no matter what it is we define for this, if we are having A back, then this A or what we combine it with has to be our identity element. So how do we want to go about this? There are two ways. We can either use the column or the row. So can either use the column or the row. So let's use the column. Let's use this part of the screen that is A, B, and C. You can see that this is my what's it called? This is my column, and then this is my row. So let's use the column. So what are the members I'm having in the column side? The first box, the one directly underneath the operation star. So here I'm having, so let me clean this so it shouldn't be confusing. Okay. So remember, the question asks us to find the identity element. So I will take this, that's this letter I'm saying here. So what do I need to combine to A that gives me A? So I don't know what it is, but I know that I want to combine something with A underneath this operation, and I want my result to be A. Now take this again. What can I see here? This is B. So what do I need to combine to B that gives me, what's it called? That will give me B. Remember, A star E must be equal to A. So what you're combining with the identity element must be equal to what you combine with the identity element. So definitely C star what will give us C. So now we look at the table. So what are we combining? Okay, where do we have A in this column? In this okay, so let me try to use a different color. So let's try to use a different color. So these elements I've written in this side of the table. So that's what I'm going to be using to determine what I'm going to fill inside of this place. Okay, so now let's see. So what am I combining, or what will I combine to A that gives me A? So if you look at the row at the top, you can see that A star A gives us A, isn't it? A star A is giving me A. So definitely my identity element for the first one is A. So let's move on to the second one. What will I combine with B that will get me B? So look at the B row or column. So on this column side, the B side. So now look at the row. So you can see here we're having B, we're having C, we're having A. So I need something to combine with B that gives me B itself. So you can say, what am I combining with B? Also A. And lastly, for the C side, what am I combining with C that gets me C? So again, it's still A. So with this, my identity element E is equal to A. I hope this makes sense. So let's do a much more complex example concerning this, and then we can call it a day on identity element. So for our final example, we're told that a binary operation, delta, is defined on a set S equal to PQRS. So of course, since we're dealing with sets, we need to write it in the proper way. So there should be a parenthesis here. Okay, so set S equal to PQRS by the following table. Show from the table whether or not there is an identity element. Show from the table whether or not there is an identity element. So this is similar to the last question we solved. Remember, in the last question, we had to look at what we can combine to that number to get the exact same number. So firstly, we want to start by writing A star E will be equal to A. So what do we need to combine to A that gives us A exactly? But of course, if you look at this table, the row written in red at the uppermost part and then the column written in red also at the in ascending order. So you can see that we have P, Q, R, and S. So definitely what we're looking at is what we can combine to P. So either we say P star what will give us P, or Q star what gives us Q, or R star what gives us Q, or S star what gives us okay, sorry about this. I wrote Q multiple times, so it should be R star E should be equal to R, and finally S star E should be equal to S. Now, is this the only way to do this? Of course not. So we can as well come from the row. Since in the last question we use this approach, so I'm saying we can also use this approach. So instead of me saying P star E, I could also say E star P should be equal to P, or E star Q should be equal to Q, or E star R should be equal to R, or E star S should be equal to S. So we want to find out what E is. E is for P, what E is for Q, what E is for R, what E is for S. So remember the question said we should show from the table whether or not there's an identity element. So if there's an identity element, what will be the value of the identity element? Okay, so without wasting much time, so let's try and see how we can solve questions underneath this. So firstly, we start by using this approach, we can say, okay, so what do we need to combine to P to get P? What do we need to combine to Q to get Q? What do we need to combine to R to get R? And what do we need to combine to X to also get X? Okay, so dash that P equal P. Of course, we know it to be an identity element, but this time around, P, Q, R, and S are looking at the elements in our row, in the first row, so not the first column this time around. So let's start with, so what do we need to combine to P to get P? So where do we have P? Here. So you can see we're having P here. So this is P, this is the result. And what are we combining with P to get P? So you can see it is R. So that means definitely. So let's use another color for this. Let's use, okay, so let's say R is my identity element. So I'm combining R to P to get P from this table. You can see that P star R, Abi, is giving us P itself in this part here. Okay, so for the next one, what do I need to combine to Q to get me Q? So come to Q again. So come down, you can see Q, the identity element of Q is still R. So this is R, so you can see what we are having here. And what do we need to combine to R to get R? So you can see from the table again, R, so where can I see R here? I'm seeing R here. So combine R to R, and then I'm having something like this. So you can see at this junction. So finally, what do I need to combine to S to get S at this junction here? So you can see combine X to R. So we have what's it called? R star S gives us X. Now, is this the only way to do this? Definitely not. I only did this because I was using the first row, P, Q, R, and S. What if I want to use the column instead? I don't want to use the row. So again, at the P, so I'll look at what I need to combine to P to get me R. So you can see that P, so this is the result I mean, this is P. So what am I combining to P? This is R, so which is still what we said there. And then for Q, still R. For R, still R. And then for S, also still R. So this is how we find the identity elements when we are given a table. In our next video, we'll be looking at the last part of this series, the inverse property, how to find the inverse property of a binary operation. So if this video has been helpful to you, so do well to like, share, subscribe, and drop your comments for other topics that you might be interested insane videos on that. Thank you for watching. God bless and bye bye.